Ever really stop to think about who's pulling your strings?
Hmm.
You probably feel like, every decision is yours, totally clear, totally you.
Right, that feeling of being in the driver's seat.
Exactly. But what if your brain have other plans? What if a huge chunk of what's happening inside your head is something you're simply not aware of at all?
It's a really fundamental question, isn't it? That feeling of being completely in charge, it feels so central to who we are.
Hmm.
But the deeper we dive into neuroscience, the more we find these, well, hidden processes. It's almost like a massive backstage crew running the show we think we're starring in.
That's a great way to put it. So for this deep dive, our mission is basically to peel back the layers on what's often called the biggest mystery in science today, the brain.
Yeah, this incredible organ.
It's responsible for every single facet of your personality, everything you think, everything you feel. It makes you you.
Fundamentally.
So we're going to journey to discover what truly drives the decisions we make and explore how that powerful feeling of having like a single person inside your skull can actually be this masterful illusion created by a symphony of almost, 90 billion neurons?
Around that, yeah. It's staggering. And we'll uncover some truly surprising insights that pop up when the brain's coordinated machine goes a little out of sync.
Out of sync, like.
Well, think about common stuff like sleepwalking or the profound unconsciousness from anesthesia, and even the really unique kind of mind-bending cases of split brains.
Okay. And we won't just stay inside the skull, right? We'll also look at how external forces, things like your everyday social interactions, even deep-seated ancestral trauma, how they subtly shape your actual biology.
Absolutely. It turns out our sense of control can be surprisingly fragile.
But here's the twist, the paradox you mentioned. Sometimes actually letting go of conscious control can lead to truly amazing results, even really creative ones.
Exactly. So let's start by just acknowledging the sheer complexity.
Yeah.
Your brain. It's this dense, intricate, 3-pound lump of matter.
Right.
Yet we have virtually no awareness of most of what's going on inside it. So many processes are just running constantly below the surface.
Like the inside of a clockwork, you said. Hidden gears and springs.
Precisely. Just humming along.
It's genuinely astonishing how much of our everyday existence just operates on autopilot. Take, sleepwalking. That's pretty common, right?
Relatively, yeah.
And people perform really complex behaviors, walking, talking, eating, sometimes even like driving,
Yeah.
all with little to no conscious awareness or control.
It's true. And you hear these accounts from sleepwalkers. Things like, I didn't do that. That's not possible. That's just not me.
Wow.
It's a remarkable glitch, really, that illustrates the point perfectly. During deep, slow-wave sleep, that's the deepest phase.
The really restorative part.
Exactly. Your prefrontal cortex, think of it as your brain's CEO, the decision maker, responsible for deliberate choices, self-awareness. It largely stays asleep.
Okay, the CEO is out.
Right.
Great.
Meanwhile, other parts of the brain, like the motor cortex for movement, the visual cortex for processing sight, areas for balance, even speech, they can become quite active.
So even though someone might look like they're up and about, crucial brain regions are still deep asleep.
And this reveals a really profound insight, wouldn't you say?
Yeah, what's that?
That consciousness isn't just an on or off switch.
Not all or nothing.
Right. Your unconscious brain is handling this vast array of daily tasks for you, regulating your heart rate, your temperature, digesting your food.
Thankfully, I don't want to have to think about digesting.
Exactly. You don't have to consciously oversee all that.
Okay, so if sleepwalking is like a localized glitch, then general anesthesia, that's something different, more profound.
It's profound and, importantly, controlled removal of conscious experience altogether. Anesthesiologists, they work to ensure 3 things: no pain, no movement, and crucially, no memory during surgery.
Right. I remember seeing this during some early research I was involved in. When you're awake, fully aware, your brainwave activity on an EEG. It looks really diverse, dynamic, like a lively conversation.
Lots of different frequencies, complex patterns.
Yeah. But when those anesthetic drugs hit the brain, that activity just dramatically changes. It becomes dull, slow rolling waves, almost like an unintelligible hum.
The drugs are essentially disrupting the sophisticated communication among different brain regions. That intricate network chatter just quiets right down.
And is there one specific area that's key?
Well, what's particularly interesting here is the role of the thalamus. Think of it as a central relay station.
Yep.
It handles all sorts of information processing, auditory signals, visual input, pain messages. So if you had to pick one brain center that could fundamentally knock you unconscious,
The thalamus would be it.
It would be a top candidate. Yeah, because it's so central to that network activity. It's like shutting down the main hub.
So what this really highlights then is it's not about just one single brain region turning off.
No, not simply that.
It's the level of dynamic, interconnected communication across these vast networks that seems to be responsible for consciousness, for that fundamental feeling of being you.
Precisely. Which leads us beautifully to another really astounding example of the brain's structure and how that feeling of a unified self can actually be fragmented.
Okay, where are we going now?
To the unique cases of people who've undergone split brain surgery.
Ah, right. This is where they sever the connection between the two halves of the brain.
Exactly. They cut the corpus callosum, this massive bundle of nerve fibers connecting the two hemispheres. It's usually a last resort to treat really severe epilepsy.
And the result is just mind-bending, you said.
It really is. It's almost as if you end up with two separated minds operating within one system.
Two minds in one head. How do you even test that?
Well, you can literally put it to the test in the lab. For someone like you, or me, with an intact brain, try drawing two different shapes simultaneously, one with each hand, like a circle and a square.
Oh, that sounds hard. Your hands would interfere, right?
Incredibly difficult. Your motor commands just get tangled up. But for someone whose hemispheres are disconnected,
They can just do it.
easily, there's no interference. It's almost like there's one mind smoothly controlling the left hand and a completely different mind controlling the right hand. Zero crosstalk.
Wow. Okay, so it's not just movement that gets split. What about other functions?
Well, think about specialization. Your left brain primarily handles language and speech, right?
Right, the talking side.
And the right side is generally more crucial for processing emotions, spatial awareness, recognizing faces.
Okay.
So in experiments, if you show a split brain patient something only to their right hemisphere, say, by flashing an image in their left visual field.
Which goes to the right brain.
Exactly.
Yeah.
They actually can't verbally report what they saw
Why not?
because their left talking hemisphere simply didn't get the message. It's completely unaware, even though their right brain clearly saw it.
Whoa. So one part knows, the other doesn't.
Precisely. There's a really famous experiment with a patient known as Joe. They flashed the word Texas to his nonverbal right hemisphere.
Okay. So he couldn't say Texas.
Couldn't say he saw anything. Yet, with his left hand, which is controlled by that right hemisphere,
The one that saw Texas.
he could draw Texas upside down.
Yeah.
And later, when they asked him to draw something that goes with the word he'd been thinking about, he drew a cowboy hat.
No way. So his right brain totally got it?
Absolutely understood. Even while his left talking brain remained utterly confused, trying to make sense of why his hand drew a cowboy hat. It couldn't access that knowledge.
That is fascinating. So what this really reveals is that the I we perceive, it's not this single perfectly integrated thing.
Not at all.
Our mind is actually like a collection of many different pieces all doing their own thing.
Kind of like a committee, yeah. Lots of different modules working together, sometimes separately. And that powerful feeling of unity, of being me, is truly an emergent property. It's stitched together somehow from the activity of billions of neurons.
An emergent property.
Wow. It's easy to think of the brain as just this isolated command center in our heads.
Right.
But the truth is far more interconnected.
How so?
Well, what's truly fascinating is how our brains are constantly being influenced by the world around us, especially by other people.
Ah, the social aspect.
Exactly. Our brains have evolved to effortlessly reason about others. A huge portion of our neural real estate is devoted just to understanding them, their intentions, their feelings. How we act, even who we feel we are, is profoundly shaped by the expectations and actions of those around us.
And that must include our emotions too, right? How they play into decisions, especially social ones.
Definitely. There's a neuroscientist, Luke Chang, who studies this using something called the trust game.
Okay, what's that?
Participants choose whether to be greedy and keep all the money from an investment or be generous and give some back to their partner.
So it taps into feelings like greed or maybe guilt?
Precisely. And what they found is that a specific brain region called the insula acts kind of like the brain's thermometer for gut feelings.
Gut feelings like
That pang of, ooh, I'd feel really bad if I kept all the money. It helps us avoid harming others, basically.
Okay, so the insula feels the guilt. Then what?
Then the prefrontal cortex, remember our CEO,
Yeah, the decision maker.
it acts more like the brain's thermostat. It takes those emotional signals from the insula and other areas, processes them, and then regulates our behavior based on them. Decides whether to act on the greedy impulse or the guilty feeling.
Huh. That intricate dance between emotion and decision making. It becomes incredibly clear in those rare cases, like Phineas Gage, right?
Oh, the classic example. The railroad foreman, 1800s, survived an iron rod blasting right through his prefrontal cortex.
Miraculous survival, but...
But his personality completely changed. He retained memory, language, basic functions. But he became, as reports say, fitful, irreverent, profane, no filter, impulsive.
It was a shocker for science back then, wasn't it? Showing that specific parts of the brain, especially those involved in emotion and that executive control, they dictate our very personality, even our sense of morality.
Absolutely.
Yeah.
It drives home the point that emotions aren't just noise. They often help us make better decisions, especially complex social ones where avoiding harm to others is a key goal.
Okay, so social interactions shape us, emotions guide us. But the influence doesn't stop there, does it? You mentioned something even deeper reaching across generations.
Right. This is where it gets really revolutionary. The concept that experiences, especially really profound trauma, can actually impact brain biology across generations through something called epigenetics.
Epigenetics. So not changing the genes themselves, but how they're expressed.
Exactly. Take the Dutch famine during World War II, a terrible period of starvation. Research found that people who suffered the starvation later had children and even grandchildren with a higher risk of metabolic issues like obesity and diabetes.
Wow. So the grandparents' experience affected the grandkids' biology.
It appears so. It's not about the genes being permanently altered, like a mutation. It's about how your environment and experiences can leave marks, chemical tags, on your DNA that change how those genes are activated, turned up or down in your body and brain.
That's incredible. Is there, like, experimental evidence for this, too?
Oh, yeah. Bianca Jones Marlin's research on mice is a beautiful illustration. She paired a specific smell, almond, with a mild electric shock for some mice.
Okay, classical conditioning.
Right. And they found, unsurprisingly, that these mice grew more cells in their noses, specifically responsive to that almond scent. They became more sensitive to it.
Makes sense. But here's the epigenetic part.
Here's where it gets really interesting. Their offspring, next generation, were born with more of these specific almond receptor cells in their noses.
Born with them, without ever experiencing the shock themselves.
Exactly. It showed a kind of memory being maintained, not just in the individual mouse's brain, but somehow passed down through the sperm and egg. It was then represented biologically in the offspring.
That's almost like evolution happening in a single generation.
It's mind-blowing, isn't it? A biological echo of the parent's experience.
So putting it all together, every experience, every thought, every sensation, from a quick social interaction to the echoes of your ancestors' traumas, it's all subtly changing your brain.
Constantly reshaping it. We are truly not just isolated individuals. Our brains are influenced by our social networks, our culture, our genetics, our development, and, yes, even our family's deep history.
And yet, despite all these influences, all this stuff happening below the surface, we still often feel like we have absolute unwavering control over our actions.
That powerful feeling of agency, yeah.
Yeah.
But as we've kind of explored, our sense of control isn't always quite what it seems.
It really isn't. I saw a neuroscientist do this amazing magic trick recently. He seemingly predicted a word I'd choose from a book and even which seat I'd pick in a row of chairs.
Oh, wow. How did that feel?
Honestly, for a second, I felt like I was back in high school trying to explain why I missed my homework, completely denying that I had actually made the choice. It really made me question how much I was actually choosing versus just being subtly nudged.
That's a perfect example.
Wow.
And experiments using technology like transcranial magnetic stimulation, or TMS, highlight this fragility even more clearly.
TMS, that's
Yeah.
where they use magnetic fields to stimulate brain areas, right?
Exactly. Researchers can use a focused magnetic pulse to, say, make a volunteer's finger jump involuntarily. They don't mean to move it, but the magnet makes it happen.
Okay.
But here's the kicker. They did another version. They asked the volunteer to intend to move their finger whenever they felt like it. And sometimes, at the exact moment the volunteer was initiating their own movement, the researchers zapped the motor cortex with TMS, causing the finger to move.
Okay, so the TMS pulse coincided with their intention.
Right. And in those cases, the volunteer almost never felt like they had initiated the movement. They'd say, oh, the computer made my finger move that time.
Even though they were intending to move it just then.
Even though their intention and the movement happened at the same time. It truly demonstrates how fragile our sense of agency is. It can be manipulated almost like a visual illusion tricks your eyes.
So our experience of making a choice, of acting voluntarily, it's often kind of retrospective. Like the brain looks back at what the body just did and decides, yeah, that looks like something I meant to do.
That's a really good way to think about it. It constructs the feeling of free will after the fact in many cases.
Wow. Okay, so if our sense of conscious control is so surprisingly fragile, maybe even a bit illusory sometimes, what happens when we intentionally try to let go of it?
Now that's the fascinating paradox we hinted at earlier. Sometimes letting go of that tight conscious control can lead to amazing results.
How so? Like in creativity?
Exactly. Think about freestyle rappers improvising. Researchers put some incredibly talented rappers in an MRI scanner while they were freestyling.
Okay, what did they see?
They found something really surprising. When the rappers were really in the zone, in that state of flow, just letting the words come, the prefrontal cortex.
The CEO again. The part involved in effortful self-monitoring, planning, filtering.
That's the one. It actually seemed to turn off or deactivate significantly.
It turned down when they were performing best.
Yeah. It's like the conscious critic, the overthinker, got out of the way to let the more automatic creative processes flow freely.
That makes sense when you think about athletes, maybe, like a pro tennis player or someone shooting free throws.
Perfect analogy. Once a skill is deeply learned, it becomes automatic. Conscious overthinking, like focusing on the stakes, I'm going to get $1 million if I make this next shot,
Yeah.
that can actually hinder performance. That's when they choke.
Right. They get in their own head.
Exactly. It's
Yeah.
counterintuitive, but often the brain performs best, especially on complex learned skills when the conscious mind gets out of its own way.
So life isn't scripted. Every human is inherently creative in some way. And by maybe decreasing that hyperactivation in the prefrontal cortex, by just letting go, sometimes we can actually gain control in a different, maybe more profound way and enhance our performance.
I think that's a fantastic takeaway. It highlights that we are all these multifaceted, multidimensional people capable of so much more than just our conscious plans and intentions.
So, okay, let's try and bring all these threads together. What we're saying is your brain. It's this magnificent, incredibly complicated collection of intricate parts, many of them operating unconsciously.
Right, all working in this delicate, continuous dance to create your perception of yourself.
And that powerful feeling of unity, of being a single me, is in a way an extraordinary illusion, beautifully produced by billions of neurons, all collaborating.
An emergent property of that complex system.
And you can't consciously control everything that makes you who you are. You can't control echoes of past trauma, maybe, or the subtle emotions of others impacting you, or all those hidden forces deep inside your own brain.
No, much of it is beyond direct conscious command.
Yet, becoming more aware of these unconscious processes, understanding them better, that isn't about losing control, is it?
Not at all. I think it's about gaining a deeper, more nuanced understanding of what truly drives you.
And by understanding these hidden forces, maybe you can begin to consciously influence and nurture the unique aspects of yourself, the parts you can shape.
That's the hope, I think. Gaining insight allows for more intentional cultivation of who you want to be. While we all strive to be the authors of our own stories,
Yeah.
it's crucial to remember the vast majority of our brain's remarkable work happens entirely outside of our conscious awareness, under the hood.
So the final thought for everyone listening, with this new awareness of your brain's hidden forces, its complexities, its illusions,
Yeah.
how will you choose to consciously author the next chapter of your story?